Hey everyone, this video will be going through the naming and structure of organic compounds for HSC chemistry. The prefix in the name of every organic molecule represents the number of consecutive carbon atoms in the molecule. When there's only one carbon, the name of the molecule starts with meth. When there are two consecutive carbon atoms, the name of the molecule starts with eth. And when there are three consecutive carbon atoms, the name of the molecule starts with prop. When there are four, the prefix is but. And when there are five, the prefix is pent, hex for 6, hept for 7, and finally oct for 8. In HSC chemistry, you only need to know the prefix naming for the first 8 carbons. You should focus on remembering the naming convention for the first 4 carbon atoms, that is meth, eth, prop, and but, because from 5 to 8, the prefix are also seen in the name of regular polygons in maths. Pent for pentagon, hex for hexagon, heptagon, and octagon. The only names that are not seen in geometry are the ones for the first 4 carbons. By way of review, when there are multiple different functional groups in a molecule, we need to arrange them in order of priority. Functional groups with higher priority will be given a suffix in the name, whereas functional groups with lower priority will be given the prefix of the name. We'll go through each functional group individually and discuss how their priorities will affect the names. Starting with alkanes, the names of alkanes will end with the suffix of A and E. When there are 4 consecutive carbons in the molecule of alkane, this is called butane, where the prefix but represents the number 4. In this molecule, we can count 1, 2, 3, 4, 5 consecutive carbons, and that leaves behind 2 carbon atoms in an ethyl group. So the name of this molecule will end with the suffix pentane, and the ethyl group is on the 3rd carbon, so therefore this is called 3-ethyl pentane. Alkenes are hydrocarbons that contain a double bonds between carbon atoms. In most cases, you will have to denote the position of the double bond. In this molecule of alkene, the double bond is in the first of the 3 positions. Therefore, this is called but-1-ene. Remember that we always should count the carbon chain in such a way so that the functional group receives the lowest number possible. So this is the reason why this is but-1-ene instead of but-3-ene. In this molecule, we can count 1, 2, 3, 4 consecutive carbons, and the double bond lies in the first bond position. So this is again but-1-ene. In addition to the butene chain, there are 2 methyl groups lie on the 3rd carbon, and there's 1 bromine substituent on the 4th carbon. Bromine is denoted by the prefix bromo, whereas the methyl groups are of course denoted by the word methyl. When there are multiple substituents or branches in the molecule, you need to write the names of the branches in alphabetical order. So this will be 4-bromo, and there are 2 methyl groups on the 3rd carbon, so it'll be 3,3 dimethyl but-1-ene. Just as a side note, the prefix di, denoting the presence of 2 methyl groups, is not considered when you're arranging the branches in alphabetical order. Alkynes are hydrocarbons with triple bonds between carbon atoms. In this case, there are 1, 2, 3, 4, 5 consecutive carbon atoms, and a triple bond lies in the first bond position. So this will be called pent-1-ine. In addition to the main carbon chain, you have a chlorine group, which is represented by the word chloro, and a methyl group on the 4th carbon. Since chloro, C, comes before methyl, we'll write chloro first. So this is called 3-chloro, 4-methyl, pent-1-ine. Alcohols are molecules with the OH group on a carbon atom that only has hydrogen-carbon single bonds. The presence of alcohols is denoted by the suffix OL. In the first example of alcohols, there's 1, 2, 3 consecutive carbon atoms. This molecule will be called propan-1-ol. The prefix prop represents 3 consecutive carbons, and since the alcohol is in the first carbon, this is denoted by 1. Propan-1-ol is a primary alcohol because the carbon atom that is connected to the alcohol group is only next to one other carbon atom. In this molecule, there's again 3 consecutive carbon atoms, but now this time the alcohol functional group is attached to the 2nd carbon atom. The name of this molecule is propan-2-ol. Propan-2-ol is classified as a secondary alcohol because the carbon atom that's connected to the alcohol is next to two other adjacent carbon atoms. In this molecule of alcohol, there's also 3 consecutive carbon atoms, and the alcohol is attached to the second carbon atom. So this is again propan 2O. In addition, there's also a methyl group attached to the second carbon, so we'll write this as 2-methyl propan 2O. This is classified as a tertiary alcohol because the carbon atom that is bonded to the alcohol is adjacent to 3 other carbon atoms. In this molecule of alcohol, there's 1, 2, 3, 4, 5 consecutive carbon atoms, and the main alcohol functional group is attached to the third carbon atom. This will be called pentan 3O. The presence of bromine is denoted by bromo, and the presence of the carbon hydrogen is noted by methyl. Since B comes before M in the alphabet, we'll write bromo first, which is 2-bromo, 4-methyl pentan 3O. Sometimes in a molecule, there can be more than one alcohol functional group. In this case, there are 2 carbon atoms, so this would be called ethan 1,2-diol. Diol here refers to the presence of 2 alcohol functional groups. Sometimes the alcohol functional group can be also present alongside an alkene functional group. Now recall that alcohols have higher priority than alkenes, so we need to give the alcohol the lower number compared to the alkene. As a result, we'll be counting the carbon atom from right to left, 1, 2, 3. There are 3 consecutive carbon atoms, so this will be called propan 2N1O. The double bond is in the second bond position between the second and third carbon atom, and the alcohol is attached to the first carbon atom. In organic chemistry, there are a group of organic molecules known as carbonyl compounds. These functional groups all contain a carbon to oxygen double bond, as I'm circling around here. This bond is called a carbonyl bond. Typically, we refer to the carbon atom that has a double bond with oxygen as the carbonyl carbon. So there's carbonyl carbon here, carbonyl carbon here, carbonyl carbon here, and the carbonyl carbon here. In aldehyde, the carbonyl carbon is between a carbon atom and a hydrogen. In a ketone, the carbonyl carbon atom is between 2 other carbon atoms. And in a carboxylic acid, the carbonyl carbon is next to a carbon atom and an OH group. In an ester, the carbonyl carbon is between a carbon atom and an oxygen, but then this oxygen is attached to another carbon atom instead of a hydrogen that we will see in carboxylic acid. In an amide functional group, the carbonyl carbon is next to a carbon atom and a nitrogen atom. In an aldehyde, the carbonyl carbon is between a carbon atom and a hydrogen atom. The suffix of an aldehyde ends with Al. The way you can remember this is that the beginning of aldehyde it also starts with Al. In the first molecule, there are 3 consecutive carbon atoms. Therefore, the name of this molecule is propanal. Because an aldehyde functional group is always at the end of the molecule, we do not need to number the position of the aldehyde functional group because we assume that it's always on the first carbon atom. In the second molecule, there are 1, 2, 3, 4 consecutive carbon atoms. And again, the aldehyde will be presumed to be on the first carbon. So the name of this molecule is butanal without any numbers. And in addition, there's a methyl group on the second carbon atom and a fluorine atom on the third carbon atom. Since fluoro, F comes before M, we'll write down 3-fluoro before the methyl, 3-fluoro, 2-methyl butanal. Aldehydes have higher priority than ketones, alcohols, amines, and alkenes and alkynes, but lower priority than carboxylic acids, esters, and amides. In a molecule containing an alcohol and aldehyde, the suffix will be given to the higher priority aldehyde group, and therefore the alcohol will be named using its prefix, which is called hydroxy. Therefore, the name of this molecule is 3-hydroxypropanal. In a molecule containing 2 aldehyde functional groups, we can denote this by writing propan-diol. The letters di denotes the presence of 2 aldehyde functional groups. A ketone functional group is where the carbonyl carbon is sandwiched between 2 other carbon atoms. The ending of a ketone is in its name, O-N-E, one. When there are 3 consecutive carbon atoms, this is called propanone. we don't need to use a number 2 to denote the position of the ketone functional group because a ketone must have a minimum of 3 carbon atoms. So in other words, the ketone functional group can only be on the second carbon atom. In this molecule, there are 3 different functional groups. There's an aldehyde, a ketone, and an alcohol. Aldehydes have higher priority than ketones, which has higher priority than an alcohol. So in other words, the suffix for this molecule will be for the aldehyde, which will be Al, and the presence of the ketone and alcohol will be denoted by the prefixes. The prefix for ketone is oxo, and the prefix for alcohol is hydroxy. In this molecule, there are 5 consecutive carbon atoms. So the ending of this name will be pent-tan-L. Since H comes with an O on the alphabet, we'll write hydroxy first. So this will be 4-hydroxy with 3-oxo-pentanal. Carboxylic acids are molecules where the carbonyl carbon is sandwiched between a carbon atom and an OH group. The suffix for carboxylic acid ends with oic acid. In the first molecule, there are 3 consecutive carbon atoms. Therefore, the name of this compound is propanoic acid. In the second molecule, there are again 1, 2, 3 carbon atoms, but there's a methyl group on the second carbon atom. Therefore, this is called 2-methyl propanoic acid. Since acids are proton donors, when carboxylic acids give away their proton, they form the conjugate base known as carboxylate ion. And this is where the OH group becomes an oxygen with a negative charge. The suffix for carboxylate ions is OH. In the first molecule, there are 2 carbon atoms. Therefore, the carboxylic acid that produced this carboxylate ion will be ethanoic acid, and this will be called ethanoate. The other common name for ethanoate is acetate, which you may have come across already. Ethanoate is the IUPAC systematic name, and this is the one you should be using for exams, whereas acetate is the name that you hear more commonly. There are 3 consecutive carbon atoms in this carboxylate ion, so the carboxylic acid used to produce it will be propanoic acid, and the name of the carboxylate ion will be propanoate. It is very useful to know and remember that carboxylic acid has the highest priority out of all organic functional groups, which means if there are any other functional groups present in a carboxylic acid, they will be denoted by the prefix, while the carboxylic acid will be denoted by the suffix. In a molecule where there's an alcohol and a bromine, both of these branches or functional groups will be denoted by their respective prefixes, so bromo for bromine and hydroxy for alcohol, and the carboxylic acid will be left as its suffix as usual. So there are 4 consecutive carbon atoms, therefore the ending of this word is butanoic acid. Since B comes with a H, the bromo will be written first, so this will be 4-bromo, 3-hydroxy butanoic acid. For the second molecule, again, we've got methyl groups and an alcohol, which will be all denoted as branches and prefixes. The carboxylic acid will be, again, written as its suffix. So there are 3 consecutive carbon atoms. Therefore, this is propanoic acid. So this will be 3-hydroxy. There are 2 methyl groups on the second carbon. So this will be 2,2-dimethyl propanoic acid. In this molecule, there's an aldehyde functional group, and there's also a carboxylic acid functional group. If the aldehyde is at the other end of the molecule, opposite to the carboxylic acid, it's actually denoted by the prefix oxo, which is usually reserved for ketones. There are 3 consecutive carbon atoms. Number 1 is given to carboxylic acid because it has a higher priority than the aldehyde, and therefore the aldehyde will be given the number 3. So this molecule will be called 3-oxopropanoic acid. In the molecule on the right-hand side, we've added another carbon atom and hydrogen to the middle carbon. In this case, we actually count the carbon atom like this, where what seems to be a methyl group actually becomes part of the main carbon chain. This allows the aldehyde to become a branch, which is denoted by the prefix of aldehyde, formyl. Therefore, the name of this molecule is 2-formyl propanoic acid. So you can compare the two molecules here. If the aldehyde is at the end of the carbon chain, we describe it using the prefix for a ketone, which is oxo. If we can count the carbon chain such that the aldehyde becomes a branch rather than part of the main chain, we'll denote it using its usual prefix, which is formyl. Esters are carbonyl compounds where the carbonyl carbon atom is next to a carbon atom and an oxygen where the oxygen is further bonded to another carbon atom. The name of the ester comes in two words or two parts. The first part is named by considering the carboxylate ion part of the ester. Remember that carboxylate ion is the conjugate base of carboxylic acids. So there are two carbon atoms in the ester, which means this will be called ethanoate. Attached to the ethanoate is one carbon and three hydrogens, which is similar to what we call a methyl group. Therefore, we'll call this methyl ethanoate as two separate words with a space in between. In this molecule, again, let's consider the carboxylate region, so that's ethanoate. And now there are two carbons on the other side of oxygen, so this is called ethyl ethanoate. What about this one? So this is again ethanoate. And now there are three carbons on the other side of the ester. This is called propyl ethanoate. In terms of naming priority, esters are second to carboxylic acids and above everything else. This means when you have a carboxylic acid and ester in the same functional group, the ester will be named according to its prefix. In other cases where the ester is combined with anything below this list, the ester will take its usual name, while the other functional groups will be denoted by the prefixes respectively. In this molecule, there's an alcohol, an ester functional group, and a bromine. Since esters have higher priority than alcohols, we'll name this according to the normal name of the ester. First of all, the carboxylate part here has two carbons, so we'll name this as ethanoate as usual. Here, since we have an alcohol attached to the second carbon of the ethanoate, we'll name this as 2-hydroxy ethanoate. There are two other carbon atoms on the other side of the oxygen in the ester, and this is normally named as ethyl. And the bromine atom is on the first carbon of the ethyl group, so we'll call this 1-bromo-ethyl space 2-hydroxy ethanoate. In this molecule, there's a carboxylic acid, which has a higher priority than the ester on the other side of the molecule. This means the carboxylic acid will receive the suffix, and there's only one carbon, so therefore this is methanoic acid. This carbon atom is not included in the main carbon chain because it is part of the ester branch. The prefix of an ester is generally described as alkoxy-carbonyl, where the carbonyl denotes the carbonyl carbon, and alkoxy describes the number of carbons on the other side of the oxygen. In this case, there's only one carbon atom, so therefore this is called methoxy-carbonyl. The methoxy-carbonyl, which is the ester, is bound to the first carbon of the methanoic acid. So we'll name this as methoxy-carbonyl methanoic acid. We do not need to number the methoxy-carbonyl because there's only one carbon on the methanoic acid. If there were more carbon atoms, you will need to write a number in front of the ester branch. Amines are molecules where a nitrogen atom is connected to a carbon atom that has single bonds only. The suffix of amines is easy because it literally ends with amine or amine. In this molecule, there are 4 consecutive carbon atoms, and the amine functional group of the nitrogen atom is bonded to the first carbon. Therefore, the name of this molecule is butan for 4, 1-amine. In this molecule, there are 3 consecutive carbon atoms, and the amine group is on the second carbon, so this is called propan-2-amine. These two amine molecules are classified as primary amines because the nitrogen atom is only bonded to one carbon atom. So you can see one carbon atom, one carbon atom. In other cases, nitrogen atoms can be bonded to more than one carbon. In this case, the nitrogen atom is bonded to two other carbon atoms, and these are therefore described as secondary amines. The naming of secondary amines are different to primary amines. First, we need to identify what's the greatest number of carbon atoms consecutively that contains the amine functional group. In this case, there's 2. So the suffix of this name will be ethan, amine, or ethanamine. The remaining carbon will become a branch. So in this case, this is a methyl group. The methyl group is connected to a nitrogen atom, so we'll denote this using the letter N instead of any numbers, N-methyl ethanamine. In this molecule, there is 1, 2, 3 consecutive carbon atoms that contains the amine functional group. Therefore, the ending of this name will be propanamine or propanamine. The methyl group is again on the nitrogen atom, so we'll call this N-methyl propanamine. In addition, there's another fluorine atom on the second carbon of the propanamine, so we can easily describe this as 2-fluoro N-methyl propanamine. Notice how I've written the fluorine before the methyl because F comes with an M in the alphabet. A tertiary amine is where the nitrogen atom is bonded to carbon atoms only. There are no hydrogen atoms. The naming of tertiary amine follows the same rule as secondary amines. First, we identify the carbon chain that has the greatest number of consecutive carbons. There's 2 here. So this is ethanamine. The remaining carbon atoms that's bonded to a nitrogen become branches again. Now there are 2 methyl groups here, so we'll write this as N-dimethyl ethanamine. This is a tertiary amine. What about this example? Amines have relatively low priority compared to other functional groups. They are more important than alkenes and alkynes, but less important than every other functional group. So in most cases, amines, when combined with other functional groups, will be denoted by the prefixes instead. The prefix for amine is amino. So in this molecule where you have a carboxylic acid, which has the highest priority, and an amine, this will be called 3-amino because the amine is attached to the third carbon, propanoic acid. In this molecule, there's an alcohol and an amine. Alcohol has higher priority than amines, so this will be called propan-2-ol, where the suffix is for the alcohol. If we count the molecule from right to left, 1, 2, 3, the amine will be on the first carbon. So this is 1-amino propan-2-ol. Amides are carbonyl compounds where the carbonyl carbon is next to a carbon atom and a nitrogen atom. In an amide, the nitrogen atom must be right next to the carbonyl carbon. The suffix for amide is its own name, which is amide. In this molecule, there are 3 consecutive carbons containing the amide functional group, so therefore this is called propanamide. If the nitrogen atom is only bonded to the carbonyl carbon and 2 other hydrogens and no other carbons, this is what we describe as a primary amide. The way we categorize primary, secondary, and tertiary amide is exactly the same as for amines. This molecule on the right-hand side may seem to be amide, but is actually not, because the nitrogen atom is not next to the carbonyl carbon. In this molecule, there's actually an amine group and a ketone functional group. Since the ketone has a higher naming priority compared to the amine, the name of this molecule is propanone, where ONE is the suffix for ketone, and the amine group is on the first carbon. This is called 1-amino propanone. When the amine nitrogen atom is bonded to another carbon atom in addition to the carbonyl carbon, this is what we call a secondary amide. In a secondary amide, we still start counting the carbon chain that has the greatest number of carbon atoms, and of course, the first carbon is always the one that has a carbonyl group. This is called propanamide once again. The leftover carbon atom and its hydrogens becomes a methyl branch, which is connected to the nitrogen atom. So this is written as N-methyl propanamide. If the nitrogen atom is bonded to 2 additional carbon atoms on top of the carbonyl carbon, this is what we call a tertiary amide. The name of this tertiary amide also ends with propanamide because there are 3 consecutive carbon atoms. The remaining 2 carbon atoms are 2 separate methyl groups. Both are attached to the nitrogen. So this is called N-dimethylpropanamide. Cyclic compounds are organic molecules where the main carbon chain forms a ring shape. The name of cyclic compounds contain the prefix cyclo. For example, in this molecule where there are 5 consecutive carbon atoms in a ring shape, this is called cyclopentane. In a cyclic compound with 6 carbons, where this is also an alkane with only single carbon-to-carbon bonds, this is called cyclohexane. Cyclic compounds can also contain functional groups such as alkenes and alcohols. The name of this compound is cyclohexene. In a cyclic molecule, we do not need to use numbers to denote the position of the alkene functional group because it is presumed that the alkene bond lies in the first bond position. Similarly, for alcohols, the position of the alcohol functional group is presumed to be on the first carbon atom, and therefore in the name of this molecule, we do not need to use numbers to denote its position. The name of this molecule is cyclopentanol. In this molecule of cyclohexene, there's a bromine atom situated on one of the other carbon atoms. Again, we presume that the double bond lies in the first bond position. So we'll count from the first carbon here, 2, 3, 4, 5, 6. So there are again 6 carbon atoms in the ring structure, which means the name of the molecule will be cyclohexene. The bromine atom, when counted this way, will be attached to the third carbon atom. So this will be 3 bromocyclohexene. Note that I've decided to count the number of carbon atoms in a clockwise manner rather than anti-clockwise, because this way the bromine substituent will be on the third carbon rather than the 5th carbon. So although the alkene functional group will always receive the number 1 bond position, you will need to think about the direction of counting the carbon atoms in a cyclic compound. You will choose the direction that will give you the lower number for any of the other atoms or branches attached to the cyclic molecule. In this case, besides the bromine atom, we also have a methyl group. We again will count the carbon chain starting with the same carbon atom. So there are again 6 carbon atoms. So the name of this molecule will end with cyclohexene. The methyl group is now on the first carbon and the bromine is again on the third carbon. We'll write the bromine in the name first, 3-bromo, because the letter B comes before the letter M in methyl in the alphabet. 3-bromo, 1-methyl, cyclohexene. Again, notice how I haven't written any numbers for the alkene double bond because it is presumed by convention that is in the first bond position. However, I need to write the numbers for the methyl and bromo group as per convention. This concludes the video on nomenclature and structure of organic compounds.